Hello, our dear students. We are going to study lesson 7 in unit 1 in algebra, the properties of multiplication operation in Q. First, closure property. The product of any two rational numbers is a rational number. For example, Q is closed under multiplication operation, we know from the previous lesson 6. For example, if we have 3 over 5 times 1 over 4, yes, 3 times 1 equal 3, 5 times 4 in the denominator equal 20, so 3 over 20 belong to Q, so the result of multiplying two rational numbers will equal also a rational number. Number 2, the commutative property. 2 over 7 times 3 over 7 will equal 6 over 35. By exchanging the places of the rational number to be 3 over 5 times 2 over 7 will equal also the same result, 6 over 35. So the commutative property is satisfied in multiplication. 2 over 7 times 3 over 7 equal 3 over 7 times 2 over 7. The result don't change. Number 3, the associative property in multiplying rational numbers. If we have 1 over 2 times 1 over 3 inside two brackets, outside the brackets we time 7 over 5, so the result will be 1 over 6 times 7 over 5, which is equal 7 over 30. If we exchange the places of brackets, the result will be the same also as follows: half outside the brackets times 1 over 3 times 7 over 5 inside the brackets, so it will be 1 over 2 times 7 over 15, which is equal 7 over 30. Okay, for example, number 1, 1 over 2 times 1 over 8 inside the brackets. Outside the brackets there is timing 4 over 9. We get the result of the numbers inside the brackets first and then multiply them to the number outside the bracket as follows. So it will be 1 over 16 times 4 over 9. The result will be 1 over 36. If we exchange the places of our brackets to have half outside the bracket and 1 over 8 and 4 over 9 inside the brackets, the answer is still the same. Okay, and this is also the associative property. Property number 4 is the existence of multiplication identity element property, or the neutral. The neutral or the identity element in the multiplication operation in Q is, yes, 1, because if we multiply 1 by any number we get the same number. If we have a as a rational number, so a times 1 equal 1 times a equals a. 1 is the multiplicative identity or neutral in Q. Okay. Number 5, the existence of multiplicative inverse of the rational number property. For every rational number a over b except 0, there is a multiplicative inverse that is the rational number b over a. For example, if we have 2 over 5, the multiplicative inverse of this number will be 5 over 2. Negative 3 over 8, the multiplicative inverse of this number will be, yes, 8 over negative 3, and so on. So we exchange the places of denominator and numerator together to get the multiplicative inverse of the rational number. Noting that when we multiply the number, the rational number, by the inverse, the multiplicative inverse, we get, yes, we get 1, the multiplicative identity, as follows. If we have a over b times b over a, we have 1. Number 6, the property of distributing multiplication over addition and subtraction. If a and b and c are 3 rational numbers, then we have a outside the brackets times inside the brackets b plus c. So we can distribute this rational number by timing it by each number inside the bracket, as follows. It will be a times b plus a times c, and this is the distributing of multiplication over addition. It will be b plus c inside the brackets times a outside the brackets in the other side, and the result is still the same. b times a plus c times a. Now distributing multiplication over the subtraction operation, as follows. If we have a times b minus c inside the brackets, so we can distribute a over this bracket to get a times b minus a times c to be b minus c inside the brackets times a outside the bracket. Okay, the multiplicative, to have an important remark, the multiplicative inverse of the rational number is called the reciprocal of the rational number, the reciprocal of this rational number. For example, we said before 2 over 5, the multiplicative inverse will be 5 over 2. Negative 3 over 10, the multiplicative inverse will be negative 10 over 3, and so on. Now let's have some examples. Use the property of distribution to find the result of each of the following. 5 over 11 times 6 over 7 plus 5 over 11 times 1 over 7. In this example, we note that 5 over 11 is repeated 2 times, so we have it outside the bracket as, yes, a common factor to have 5 over 11, open the brackets, write the other element, which is multiplied by 5 over 11, which is equal 6 over 7 plus 1 over 7. To get the answer, 5 over 11 times 7 over 7, which is equal 5 over 11 times 1, equal 5 over 11, because 1 is the neutral. Timing 1 by any number, we'll get the same number. Another example, 9 over 17 times 21 minus 9 over 17 times 4. We notice also that 9 over 17 is repeated 2 times. We write it as a common factor outside the brackets as follows. To have 9 over 17 times 21 minus 4, which is equal 9 over 17 times 17 will equal 1, because 17 is over 1. 22 over 25 times 6 over 11 plus 5 over 11 times 22 over 25 minus 22 over 25. The repeated number here in each term is 22 over 25. we get it as a common factor outside the bracket and write the remainder inside the brackets with their signs. 22 over 25, open the bracket, write 6 over 11 plus 5 over 11 minus 1, which is equal 22 over 25. Inside the brackets we have 11 over 11 minus 1. 11 over 11 will equal 1, so 1 minus 1 equals 0. 0 times any number will equal 0 also. So the result of this example will be 0. Seven over 12 times 5 plus 49 over 12 minus 7 over 12 times 11. We noted that we have the denominator 12 repeated. 7 over 12 as a common factor outside the bracket and write the remainder elements inside the brackets as follows. 7 over 12 times 5. 49 over 12 will equal 7 times 7 over 12 as follows. Yes, we take only 7 over 12 of them outside the bracket as, yes, a common factor. So we have 7 over 12 outside the bracket. Open the bracket and write 5 from the first term. From the second term you have 7 plus 7, and the other term, the last term, will equal negative 11 inside the bracket. 7 over 12 times 12 minus 11, which is equal 7 over 12 times 1 equals 7 over 12.